Hello. I'm now going to use the actual Khan Academy website to do some more problems, and this time we're going to go the other way around. We're going to look at a trigonometric, the graph of a trigonometric function, and we're going to try to figure out the equation. So let's start with the problem we have in front of us. So we have well, we don't know if it's a sine curve or a cosine curve, but I guess it's fair to say that it's one of the two. So actually, let's answer that question first. What do you think this is? Do you think that this is a sine curve or a cosine curve? Well, what do we know? What's the difference, or what's the easiest difference to differentiate between the two? Well, what was sine of 0? And let me get a little chalkboard in here. Let me bring it right here. What is? Let me make sure my pen tool is correct. All right, right here. What is sine of 0? Sine of 0, and it could be 0 degrees or 0 radians. Well, if you remember from a couple of the other modules, or even if you want to use a calculator, sine of 0 is 0. And what is cosine of 0? Well, cosine of 0, if you remember from the last modules, or you want to use a calculator, although you shouldn't have to use a calculator for cosine of 0, you might remember it was 1. So this graph that we have here, it's definitely when x is 0, when the x-axis is 0, the function definitely isn't 0. In fact, in this case, it's 1.5. So this tells us that this isn't a sine curve, although later with shifts we'll learn that it could be a shifted sine curve, that this isn't a sine curve, that this is a cosine curve. And then you might ask, well, Sal, if this is a cosine curve, why is f of 0 equal to 1.5 or 3/2 instead of 1? Because I just said here that cosine of 0 is 1. Well, that's because there must be some type of a coefficient here, let's call it a, that is changing the amplitude of this cosine curve. And if you remember from the last module, what do you think this a is? Well, that a is just literally the amplitude of the curve. And what's the amplitude of this curve? Well, the amplitude of this curve, if we just see how much it moves above and below the x-axis, well, it's that 3/2 or that 1.5 we've been talking about. See, it moves up 3.5 and it moves down 3.5. So let me just write that. So we know that this is 3/2 cosine of, well, something x, right? We know f of x is equal to 3/2 cosine of something x. And we could use the formula that we learned in the previous video, that it equals 2 pi over the period x. So now we just have to look at the graph and try to figure out what the period of the graph is. Well, how many radians does it take for the graph to start repeating again? Well, let me click on the hint button, and maybe this will help us. When I click hint, there, it drew the period. And you could have figured it out on your own. If you just go from any point and then go follow the curve back to the same point again, you'll see how long its period is. And the hint on the Khan Academy actually told us that the period is 4 pi. And you could have started from any point to any other point. You could have gone from this point and then gone down, gone back up, come down, and then you would have seen that this distance is also 4 pi. So we know that the period is 4 pi, and then I can click hint again, and it'll tell us stuff that we already figured out. The amplitude we already figured out was 1.5. But let's just use the period, because we already knew what the amplitude is. So the period here we already figured out was 4 pi, so let's just write that in our equation. So f of x is equal to 3/2 cosine of 2 pi divided by the period. The period in this case is 4 pi x. That equals 3/2 cosine of 1/2 x. Now, if you ever forget this formula, which frankly I always do forget it, I've actually never memorized it. I just try to think about what the period would be. The way I think about it is the coefficient on the x term, that's a measure of how many cycles does the graph do within 2 pi radians. Let me see if I can explain that within the context of this problem. So this problem, if we start at 0 and then 2 pi is here, how many cycles do we complete by the time we get to 2 pi? We start here, we go back here, and then we're at 2 pi. Well, we only got halfway done through a cycle. So that's the coefficient on the x term, and that's how I remember it. So I could just say, well, that's 3/2 cosine of how many cycles do I complete in 2 pi radians? Well, I only complete half a cycle. 3/2 times the cosine of 1/2 x. So that's our f of x. Let's do another problem. All right. Okay, this one's interesting. So the first thing, just by inspection, we can figure out what this amplitude is. This is pretty easy, right? How much does it move above and below the x-axis? Well, it only goes 1. So we know that the coefficient on, or the multiplier times the sine or the cosine function, whichever this is 1. So let's write that down. Let's write down that the amplitude is equal to 1. Now let's try to figure out if this is a sine or a cosine function. In the last problem, we said, well, it's either going to be if it's sine of 0 is 0 and cosine of 0 is 1. Well, f of 0 of this function, whichever it is 0. So we know this is a non-shifted sine function. So there, we have another piece of information. It's a sine function. It's a sine function. So last thing we have to figure out, we could either figure out the period, or we could use the method that I just showed you, where we say, well, how many times does it cycle within 2 pi radians? So let's do it that way, and then we immediately know the coefficient. Let's see, it goes, well, actually, with this graph, boy, it doesn't even get all the way to 2 pi. But let's see, it goes 1 cycle, 2 cycles. And I did 2 cycles in only pi radians, right? Because I'm only at x equals pi here. So if I did 2 cycles in pi radians, then we must be able to do 4 cycles in 2 pi radians. Or we could actually start here. Actually, this is better, right? Going from negative pi to pi. That's 2 pi radians. So we finish 1 cycle, 2 cycles, 3 cycles, 4 cycles. So then we know what the coefficient on the x term is. So we know that it's sine of 4x. So the answer here is f of x is equal to 1, because that's the amplitude, which is just 1, times sine of 4x. I think we have time for one more. And I want you to, don't just mechanically do whatever I'm telling you. I want you to think about why counting the number of cycles within 2 pi radians, why that makes sense to you. Then think back to the unit circle. Or think back why that formula that, the 2 pi divided by the period is also the coefficient. Think about why that makes sense. If you realize why it makes sense, you'll never have to memorize it. And then 20 years later, when you're doing it like I'm doing it right now, you won't be confused. You'll be able to rederive the formulas. Let's do one more. All right. So what's the amplitude here? Well, let's see. The amplitude is 1/2. So let me delete the old stuff that I was writing before. For some reason, it's not deleting. Okay. Hope I don't confuse you. So the amplitude, let's just call it amplitude, is equal to 1/2. And how many cycles does it complete within 2 pi radians? Let's see. It goes, if we start here, it looks like it completes only half a cycle, right? Because it takes 4 pi radians to complete the entire cycle. So it only completes half a cycle. So we could say, well, we could think of it either two ways. We could say that the period is equal to 4 pi, because that's how long it takes to complete one cycle. Or we could say it can only complete half a cycle in within 2 pi radians. The last thing we have to figure out is this sine or a cosine function. Well, f of 0 is 0, right? So it's a non-shifted sine function. So then we're done. We have f of x is equal to 1/2. Figured out it's a sine function. Sine of what? How many cycles did it complete in 2 pi radians? It only completed half a cycle. Let me not cover the problem. It only completes half a cycle. So it's 1/2 sine of 1/2 x. Or we could use the formula f of x equals 1/2 sine of 2 pi divided by the period x, right? Because 2 pi divided by the period is equal to 2 pi over 4 pi, which also equals 1/2. I think that'll give you a sense of how to do these problems now, and I encourage you to practice them on the Khan Academy website. Have fun.